Wearable computers, advanced imaging that dissects a heart without a scalpel. These are just some of the technological advances that will be widely used. This, according to experts invited by the Institute of Electrical and Electronics Engineers to preview our future. First, a computer that makes a fashion statement. It's called Viewman 2, weighs about a pound, and is equivalent to an IBM PC. This model is programmed to do a tour of the university campus where it was built.
We have this commercially available head-mounted display called a private eye, and once we turn it on, I can now use this little hand mouse, and I can go through. I'm looking at one campus building, I'm looking at another campus building, and now I'm looking at a campus map.
With the environment high on the new administration's priority list, serious threats to our planet can be monitored more accurately by satellite remote sensing systems.
We could incorporate those capabilities that were very responsive to environmental changes, but now are focusing, of course, on a military type of targets as opposed to environmental concerns.
We can look forward to improved air quality with the development of the hybrid diesel-electric bus. It's expected to hit the streets of New York City in a couple of years.
On the order of 1,000 tons of pollutants are produced of unburned fuel a year, and 8,000 tons of NOx. Most people just aren't used to thinking of these things in that kind of quantities, but the bus fleet in New York City of 3,500 buses produces a fantastic amount of pollution. These buses will reduce those pollution levels to 40%.
Advanced MRI, magnetic resonance imaging, combined with state-of-the-art computer graphics technology will enhance diagnostic medicine. The technique, which resembles interactive video, can diagnose heart problems more accurately and, as a result, save lives.
What we'd like to develop is a comprehensive cardiac exam where the patient presents with chest pain, can come to MRI, and we would, in the space of 30 minutes, look at functional information, perfusion information, and get an entire model of the patient's heart that the physician could interact with on a computer.
These and other technological advances in medicine, transportation, and the environment are just some of the areas where engineers are improving the quality of life for people in the United States and around the world.
I'm looking at another campus building, and now I'm looking at a campus map. Now, when we want to program it for a different application, we can turn it off, and we can get a memory card and put different information in it, slide it into the unit, go off and do another application, and when we're finished, you just eject it and use it for another application.
Well, what's happening the last few years is we've seen a tremendous escalation in terms of the requirements for remote sensing that's brought about by our domestic concerns because of the hazardous waste and nuclear waste problems. And then if you add to that the concerns now on an international front with the Soviet Union's openness, and we're finding out the extensiveness of the problems there, we realize that remote sensing is going to have a lot more responsibility in terms of monitoring and contributing to the environmental activities. Well, the satellites are capable to monitor day and night through clouds, nighttime or whatever, any change that takes place on the surface of the Earth. Now, this isn't to say that we have total capabilities now to monitor all type of changes, but with the addition of new technology and the customization of technology, we could incorporate those capabilities that were very responsive to environmental changes, but now are focusing, of course, on a military type of targets as opposed to environmental concerns.
Is that it's in major cities such as in states like California and New York, it's been legislated that a certain fraction of the vehicles in the next 10 years have to be all electric, essentially zero emissions vehicles as they're referred to. And this could amount to 10% by the year 2003 of all the vehicles have to be electric vehicles, because that's the only truly zero polluting vehicle. And that amounts to a substantial number of vehicles that will be have to be electric if this legislation remains in effect. In fact, 9 of the Northeast states have adopted the California regulations or are going to adopt it. And if this all happens, 10% of the, will almost be 500,000 vehicles will be all electric in the year 2003. So that's substantial.
What are the advantages to this hybrid vehicle in terms of pollution?
The major advantage is a substantial reduction of the elements that cause air pollution in the cities. For example, on the order of 1,000 tons of pollutants are produced of unburned fuel a year, and 8,000 tons of NOx. Most people just aren't used to thinking of these things in that kind of quantities, but the bus fleet in New York City of 3,500 buses produces a fantastic amount of pollution. These buses will reduce those pollution levels to 40% of those numbers. So that's a substantial improvement in this area. At the same time, it will save on the order of 25% of the fuel, which can amount to about 16 million gallons a year. So again, a substantial amount. Plus, it gives you the opportunity to run the vehicle where it produces no pollutants at all on a purely electric mode, possibly in key areas of the city which are maybe more prone to air pollution, either from batteries on the bus or from overhead power in a trolley mode, but use the diesel maybe in the outer line areas.
How far?
A patient presently, when they have or they present with what seems to be a heart attack, is they come to the hospital, they have chest pain. And at that point, they go through a battery of tests, whether it be nuclear medicine, coronary angiography, echocardiography, to try and determine whether or not they have in fact had a heart attack and whether or not you want to do invasive therapy on that person. What we would like to do is have a comprehensive magnetic resonance imaging exam where the patient comes to the hospital, is in the magnetic resonance imager for about 30 minutes, and is asked to cooperate with someone operating the scanner, and then in short, what would come out is a computer model of that person's heart, so the physician could actually pick up the heart on the computer and look at it functioning in real time and dissect it away and look for abnormalities after one exam.
Take cover off again.
Just talk about it for a little bit.
And don't put it underneath.
Okay, the actual housing was done about the last 24 hours and came out of the rapid prototyping vat literally only about 8 hours ago.
Okay, and the top goes back on.
Okay.
And then tell us about putting a card in.
Okay, so now we need to load different information into the system, so we use a credit card sized memory card called a program. I gotta do. Okay, so we can take a programmable read-only memory card, put it in, and when we new information or new application, we just eject it, take it out, and replace it by another card.
Okay. Oh, and I'm done.
Turn it on here. Now you should put your hand down and find the
Okay, got it.
button now should get you the screen. Yeah, this one is. And every time you hit a different button, there's a different view. There's 2 campus buildings and a campus map, and this is our first prototype. So the switches, sometimes you have to play with them a little bit.
Is there any sound?
And on these 2, there is not. about 30 or 40 batteries.
And there's 3 buttons. The only 3 you press, so you press any of those buttons. Oh, yeah. She's got the